Okay, let's play with the line of best fit. Up here, as you can see, we have a scatter plot. It's got two variables. On the horizontal axis, we have the variable of age. We're going from a young kid to an older man to a very old man in a walking stick. That's the variable here in the horizontal axis down below. And the vertical axis is fitness, as fitness increases as you go up that way. Now the scatter plot over here is drawn and you can see the points, and there seems to be a direction, there seems to be a downward trend. Now what does that mean? It means, well, what do you think? As you get older, what happens to your fitness? Fitness decreases, doesn't it? And as you get younger, fitness increases. So that means there's a negative, moderate correlation between the two. Now, correlation is the measure of the strength of the relationship or the linear relationship between two variables. And these two variables, age and fitness, seems to have a negative moderate correlation. Now, how are we going to put in that line of best fit? Well, first of all, what's the purpose of a line of a best fit? The purpose is for us to be able to predict one variable given the other variable. So for example, if I had a certain age of a person, I could actually predict by going up to that line what sort of fitness level they would have based on this graph. So how do we draw that line of best fit? Well, the first thing we want to recognize is that we need to have approximately roughly the same number of points above the line as we have below the line. So for example, if we got 6 above and 6 below, that would be cool. Sometimes you might have 6 above and 7 below, that would be cool too. But you want to have roughly approximately the same number above or below. Now this line of best fit needs to represent most or all of the points as closely as possible. Now once that line is drawn, you want the distance from the points to the line to be as small as possible. And you want that line of best fit to go through as many points as possible, but not absolutely necessary. So let's go ahead. You might want to grab a clear ruler. I don't know if you can put it on the computer or on a piece of paper. Let's have a look how we go here. So let's firstly count the number of points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's an odd number. So we want 15. So now I'm going to try and put a line in there roughly by eye because it's not completely accurate because this is an approximation. We're using the eye. So I'm going to try and put it through the middle, and I'm going to put it through the middle like that. That's just rough. Okay, let's count the number of points above and below. I'll actually make it go through that point there. Okay, above we have 1, 2, 3, 4, 5, 6, 7. Below we have 1, 2, 3, 4, 5, 6. It's kind of touching 7. Well, it looks pretty equal there. But what I want to do is actually make it go through one point at least, completely through one point. So I'll make it go through this one, and I'm going to replace it so you can see where it is. Let's make it straight. Through the middle. Okay, I'll put it about there. Okay, we're going through one point. Okay, that's pretty good. Let's count the number of points above and see if it matches below. 1, 2, 3, 4, 5, 6, 7 above. 1, 2, 3, 4, 5, 6, 7 below. That's pretty good. We've got 7 above, 7 below, and it goes through one of the points. So it looks like this is the best line for the line of best fit. So there it is right there in red, and we can use that to make predictions in the future. Hope that helps. Thanks for watching.